Hello, this is Mr. Agbamu Idanogrene. I'm here to teach the topic rate of change in mathematics. And this topic, rate of change, is one of the applications of differentiation. Since we are still dealing on differentiation, so I decided to look at rate of change. Normally, in differentiation, the word dy dx, is talking about the changes that occurs in y with respect to x. For example, look at what I have here. I said if a quantity y, depends on and varies with a quantity x. Now say then the rate of change of y with respect to x is dy dx. So normally everything we do in differentiation, which is usually dy dx, is always talking about the rate of change of y with respect to x. So how is y changing when x is changing? So you can have another example. For example, look at this one. It says the rate of change of pressure with height is dp dh. So since pressure is p, height is h, we can say the rate of change of pressure with height is dp dh. But there's a very important aspect of this rate of change I want you to understand, which is this third paragraph we have here. It says a rate of change with respect to time is usually just called the rate of change. So what I want you to understand in this statement is that whenever they ask you to find the rate of change of any quantity without telling you with respect to any other quantity, just know that we are looking for the rate of change of that quantity with time. That is one important thing we are talking about. Just look at what I have here, which says a rate of change with respect to time is usually just called the rate of change. Then we now say d with respect to time being assumed. For example, let's see this example. Say for example, the rate of change of current I is di dt. Understand? In this particular one, they didn't tell us with respect to what I is changing. You see, a rate of change of current, they didn't tell us what is changing with. Since they didn't tell us what is changing with, just know that it's changing with time. So how is current changing with respect to time? So that is what this statement is talking about. When we say a rate of change of current, full stop, that means how is current changing with respect to time. So this is one important aspect we are going to do in this topic, rate of change. Then we now see another example now, and a rate of change of temperature, theta. That is all. So when you see something like this, rate of change of temperature, the full stop, all you just need to know here is how is temperature changing with respect to time. That is the theta divided by the time, like the theta the time. That is all, and so many examples like that. If you could recall your physics definition of velocity, you can see that the way they define velocity is just written as velocity is the rate of change of displacement, full stop. So that is how we define velocity. And when you want to calculate velocity, you use displacement divided by time. So how is displacement changing with respect to time? That is velocity. The same thing with acceleration. We say acceleration is the rate of change of velocity. So when they say acceleration is the rate of change of velocity, so what they mean by that is how is velocity changing with respect to time. So how do you change the velocity with respect to time? So acceleration is velocity divided by time. Change in velocity divided by change in time. So that is one of the introduction to rate of change. Let's look at an example. This is mathematics. It's only when you solve an example you can understand the topic very well. So you can see this example we have here. You can see this example. It says the rate of a circle is increasing at the rate of, the radius of a circle is increasing at the rate of 0.01. You can see the unit. The unit is very important. The unit is centimeter per second. And what is centimeter per second? This is length divided by seconds. And radius is given in centimeter. So if the radius is centimeter, is dividing by the time. So you can see it now. The radius of a circle is increasing at the rate of. So this is how the radius of the circle is increasing at this rate. So what this one means is that if we go straight to solution now, let's go straight to our solution, which is a solution now. Okay, so down to solution. What this means is that the changes, which is the radius divided by the time, will now be equals to 0.01 centimeter stroke. So that is centimeter seconds raised to power minus. So this is what this statement is talking about. So this is how the radius is changing. Take note of that. So that is what this statement is talking about. The radius of a circle is increasing at the rate of 0.01 centimeter per seconds. So radius of a circle is increasing at this rate. You can see that means the radius divided by the time is equal to 0.01 centimeter per second. So this is how the radius of the circle is increasing at a particular time. So that's what is given first. Then now we should find the rate at which the area is increasing. So now the question is, find the rate at which area is increasing when the radius of the circle is 5 centimeters. So what they want us to calculate now is this one now. Find the rate at which the area is increasing. So that means the area, let's take capital A as area, the A dt. So this is what the question wants us to find. The A dt is equals to, we don't know this now. Let me delete this. It will be equals to question mark. We don't know it. So this is what the question wants us to find, and this is what has been given. All I want you to understand in this topic, rate of change, is check what is given. The rate of what is given is what? Look at the unit. Most times the unit will guide you in case you don't understand. The question is talking about the radius of a circle is increasing at the rate of 0.01. You see the unit centimeter, which is for radius. Radius is in centimeter divided by time. So that means change in radius divided by time. That is change in radius, the radius divided by the time, the r, the time is given. Then the question now says we should calculate what? We should find the rate at which the area is increasing when the radius is, they gave the radius. So how is area increasing? So the changing in area is what they want us to calculate. So the rate of change of area is what we are calculating, which is the area divided by the time is equals to unknown. That is question mark. Then how can you solve this question now? What you need to do now is, what is changing in this question that we need to calculate is the area of that circle. Find the rate at which the area is increasing when the radius of the circle is this. So this question is talking about a circle now, the radius of a circle. And what is area of a circle? We all know the formula of area of a circle. Area of a circle is equals to pi r squared. So this is the formula for area of a circle. So everybody, I know we are used to this. It's not a new thing to us now. So if area of a circle is pi r squared, then let's differentiate it. If you differentiate it, the r, you differentiate the area with respect to r. So the r will now give us what? You remember our rules for differentiation. The power will multiply the constant in front. No, pi is a constant, which is 2 pi. So 2 pi r, then you subtract from the power. 2 minus 1 is 1. So this is the result when you differentiate the area. You can see the area has been differentiated now. We got 2 pi r. But if you look at what we are calculating, we need to calculate the a dt, not the a dr. You understand? So this is what we have here, is the a dr, and what the question wants us to calculate is the rates of this area. How is the area changing with time? That's what the question wants, and that is the t. But what we just differentiated here now is the a dr. So how can we get the a dt? So we can use our knowledge of the chain rule. If we use our knowledge of chain rule, Okay, let me come to this place. Don't want to move down yet. So if we move to this place now, with your knowledge of the chain rule, let me write it down. So using the chain rule, I want you to remember this. So using chain rule, if you're using chain rule, you get something like this. So remember, this is our target, the A, the T. So if I do something like this, the A, the T equals to, you see this, the A, the R, let's put it here. It's just a techniques in mathematics. Just check what I'm doing. This is what I need to calculate, equals to the A, the R, which is the A, the A divided by the R, then multiply it by the R, the T. You can see, multiply by the R, the T, which is the R, the T. So normally, if you solve this mathematics, you can see that the R will divide the R will cancel the R, then the A will divide the T, which is equal to this. You can see from this one, you can see that our solution is settled. So final answer to this question now is the A, the T will now be equals to, you can see it. So this is what chain rule is trying to tell us to do, and with the knowledge of chain rule, you can solve so many examples in rate of change. You will have no problem. So what do we have? The A, the R, we have already done it by differentiating area of a circle, which is 2 pi r. That is 2 pi r, then multiplied by the r, which is the r dt, which is 0.01. You can see there 0.01. So without wasting time, let's put the value of r. The question says we should find this rate, the rate at which area is increasing when the radius is 5. So let's just put the values we have here. In mass, we say the constant for pi, except the question wants you to leave your answer in pi. So if they don't want you to leave your answer, like this question did not tell you to leave your answer in terms of pi, so it depends. But let me just put the pi there. So if you are leaving your answer in terms of pi, it will now be 2 pi times the radius now, which is r, is 5 times 5, then times the r dt. What is the r dt? Look at it here, 0.01, 0.01. So that is all. Then multiply, you get your answer. So if I times here, this is 2 times 5 will give us 10. That is 10 times 10 times 0.01, which is going to give us 0.1 pi. So we are going to get the A dt is equals to 0.1 pi, and this is area. See, this area, so the unit is going to be centimeter square per seconds raised to power minus 1. So area is centimeter square divided by time. The t is time. So this is your answer in terms of pi. But if the question wants you to leave your answer without pi, because there are some cases whereby they will solve and don't leave the answer in terms of pi. So if you are solving without in terms of pi, your final answer now, the A, the T, is now going to be equal to, so we need to multiply 0.1 times, pi most times we use 3.142. So this is the value we use for pi most times, 3.142, and the answer gave us 0.314. So that is to 3 decimal place. That's what I did in this case, 0.314. Same centimeter square per seconds raised to power minus 1, because area is centimeter divided by seconds, which is time. So that is all. Rate of change, this is how you do it. The most important thing, as I said, read the question very well, know the rate that is given. For example, this example says the radius of a circle, so it's the radius that they focus on first. is increasing at the rate of this, so the rate of the change of radius has been given. So rate of change of radius is given, and when they give rate of change of radius, what do they mean? They mean the radius, like dr divided by dt. That is this, you get it? Then they now say find the rate at which the area is increasing when the radius is this. So find the rate at which area is increasing. So find rate of change of area. That's what they are trying to say here, which is the area dt. We don't know it. That is this. So that is the major problem. Then what next? The question is talking about area of a circle. Find the rate at which the area is increasing. That area of the circle is what the question is focusing on. Then you bring out your formula for area of a circle, differentiate it. When you differentiate it, our basic rules for differentiation says differentiation of a with respect to r will be dA dr is equals to the power will multiply the constant 2 pi, then subtract 1 from the power, which is r raised to power 1. That is this. Then when you get this, the work is over. What do you do next? The next thing you do now is use your chain rule principle. This is what you are calculating, the a dt. You can see it, the a dt. Then why not multiply the a dr? You can see by the r dt, such that if you cancel the r with the r, it's going to be equal to dA divided by dt, which is this. You can see we got this. Then after getting this, that means we have not done anything different. The equation remains the same. So since it remains the same and the ADR have a value which is 2 pi r, you substitute the value there, 2 pi r, then the r dt has a value 0.01. That is all. Then what next? Substitute the values you have. Radius is 5. You put your radius as 5 for 2 pi r. Then the r dt is 0.01. Then you calculate. If you are leaving your answer in terms of pi, this is the answer. But if you don't want it to leave it in terms of pi, you go further to 3 decimal places. This is my answer. Then remember, your unit is area divided by time. So you need to raise the area to power 2. Time is seconds, which is seconds raised to power minus 1. That is change in area divided by change in time. So this is solution to this question, and that is all I have for now. Rate of change is the topic. How does a quantity change it with respect to another quantity? But if they didn't give you what is changing with respect to, then you use time. That is what we are talking about. So look at this place. A rate of change of current is just given. They didn't give you what is changing with. So the with means with respect to time. That is what we always assume as far as science is concerned. So that is the principle we use in this topic, rate of change. So they will always give you the rate of change of a particular quantity. They will not tell you at what is changing with. So you will now use change with time. That is the knowledge I want us to gain in this topic. So in my next class, in my next video, I'm going to do like 2 or 3 more examples. Then I'll give you some work to practice. That is all I have for now. I want you to go through this video, get the fundamental of rate of change, follow this simple example. Then in the next video I have, we shall do more examples for further studies. Have a nice day.